All right, we are back. This is Techmath1. We're looking at review chapter 13, 14. This is part 3. We're picking up on number 15. Word problems. So the sum of two numbers is 46. What does that look like? That looks like this. X plus y is 46. Twice their difference is 24. What does that mean? Twice their difference is equals 24. So you have 2 times quantity x minus y. That's the big thing people get wrong here. They forget to do the quantity of. So twice the difference means you do the x minus y, the difference, and then put the 2 on the outside. So here are our 2 equations. 2x minus 2y equals 24. That and that. Again, if you want to use the addition method, multiply the top by 2, add straight down, that'll kill the y's. If you want to solve for y and sub it in, you can use substitution. I'm going to use a matrix. Do reduced row echelon form of 1, 1, 4, 6, and 2, negative 2, 2, 4. You put that in your calculator, you hit enter. It gives you 1, 0, 0, 1, the identity matrix, with the answers right there, 29 and 17. And that's it. X equals 29, y equals 17. Done. All right, 16 is, why can't I get the page to turn here? Uh-oh. I did my pages in the wrong order. All right, 16 is, let's see, there are 25 more children's tickets than adults tickets sold at a spaghetti dinner. Okay, so children's is 25 more children. So children's is, C for children's, is equals 25 more than adults, so A plus 25. All right, and then they charged $4 for adults, $2.50 for children, and sold $498 worth. So that is 4 times adults plus 2.50 times children is equal to 498. And again, you can see what they're doing here. They want us to use substitution. I'm not gonna, look, I'm gonna move minus A over there, and I'm gonna use these. I got negative 1A plus 1C equals 25. I got 4A plus 2.5C equals 498. And I'm just gonna do this again. Reduced row echelon form, RF, of negative 1, 1, 25, 4, 2.5, 498. You hit enter, you get 1, 0, 0, 1, the augmented matrix, along with the answers 67 and 92. So X is equal to, well, I guess not X, A, adult tickets were 67 adults, and C, 92 children, which coincides with being 25 more, right? If I had 25 to that, I'd get 92. And if I put those numbers back into the money equation, where was the money equation? Into this equation, I'll get 498. So you can check it back if you want to. All right, number 17, Mr. Keeley drove part of the trip at 85 kilometers per hour, and then the rain came down, and he slowed down to 75 kilometers per hour. Must be in Canada, eh? And he drove a grand total of 4 hours, and he did a complete distance of 335 kilometers. All right, so what is this going to look like? This is going to be, we got 2 different times. Distance equals rate times time. That is true. Distance equals rate times time. But we have 2 different rates and 2 different times going on here. So what we're going to do is we're going to set it up like this. Time 1 plus time rain is equal to 4. The time that he was just driving normal and plus the time that he was driving in the rain is equal to 4 hours total. So we add up those two times, it should be 4. He was traveling at 85 kilometers per hour for time 1. Distance times, or time, rate times time is equal to distance, plus you had to slow down to 75 for the rain. So again, rate times time is the distance, so that's how far he traveled in the rain. We don't know what this is yet. And then he went 335 miles. And again, you could do it if you want to do the addition method, multiply everything by negative 85 on the top, add straight down, get the T1s to cancel and solve. You can totally do it that way. I'm going to make my calculator do all the work. Reduced row echelon form, 1148575 and I'm going to hit enter and it's going to give me the two answers. It is 3.5 and 0.5. And so they asked about the rain. So this is T sub 1. So the normal driving time was 3.5 hours, but the rain was 0.5 hours or half an hour. So half hour was the rain travel. All right. Okay. Oh wait, that's right, I did them. I was like, wait, am I on the last page? No, I got to do 18 and 19 and 20. All right, so now they're playing with variables and getting rid of variables. And we did this already in way back in one of the earlier chapters. I want to say chapter 3, where they gave us formulas and we had to substitute away one of the values. So hopefully this isn't too bad for anybody. A equals KS. K is equal to W over A. And they say eliminate A, solve for K. So eliminate A, solve for K. So what does that mean? That means you're going to eliminate A by substituting. So you're going to take this KS, you're going to stick it into the other equation. So K is equal to W over KS. Now look, no more A. We eliminated A through substitution. That's going to be the way we're going to eliminate these variables that they tell us to get rid of. Always with substitution. It's the easiest way for these problems. So now we cross multiply and solve. We get K times KS, that's K squared S equals W. And then they want me to solve for K. It's too bad. If they would have said solve for W, I would just be done. I'd circle it and I'd be done. But it didn't. It said solve for K. So I'm going to divide out the S on both sides. I get K squared is equal to W over S. And then K is equal to plus or minus the square root of W over S. And again, if you put the plus or minus down, I'll give you full credit. It's there. It's just in the context of this course, they tend to throw away the negative part because it's usually distances or times or electricity, and it can't be negative. So it's fine. If you put the little plus or minus in there, we're still good. I'll give you the full credit. But if you check your answer with that back sheet, it's going to just say the square root of W over S. Make sure that I know that, the square root is over the W and the S. All right? Okay, so 19. Eliminate G and solve for R. And so F is equal to G plus QR, and R is equal to K minus G. So I'll solve for G on this one. Subtract QR from both sides. So we got G is equal to F minus QR. We take that F minus QR, you just jam it in there. So we got R is equal to K minus quantity F minus QR. We do the distributive property, so you have R is equal to K minus F plus QR. So now look, no more G. You don't have a G in that bottom line at all, but they want me to solve for R. Ooh, this is a trickier one. We have to move the QR over. But now look at what I have. I'll write it up here. I have R minus QR equals K minus F. That's what happened. I just subtracted QR from both sides. So it died on that side. It's moved over to that side. But now I want to solve for R, so I have to factor out an R, like undistributed, like the distributive property, but in reverse. So I pull a R, and then I divide by R to figure out what goes inside. R divided by R is 1. QR divided by R is minus Q. All right, and now I divide by 1 minus Q on both sides. And we're done. K minus F over 1 minus Q. Okay. Let's look at 20. Eliminate S and A. Oh, geez, Louise. And solve for W. So they want me to get rid of 2 variables. So what I'm going to do is, again, I'm going to substitute them away. Just substitute them away. So look. We've got 20. We got P is equal to SW. We got R is equal to A plus S. And we got T is equal to AW. So they want me to get rid of, eliminate S and A, and then solve for W. All right. So S is right here. Divide by W both sides. We got S is equal to P over W. A is right here. Divide both sides by W. We got A is equal to T over W. And now we're going to take this equation and we're going to sub in the T over W for A, and we're going to sub in the P over W for S to get this. R is equal to T over W plus S over, oh, wait, no S. I got rid of the S. P over W. So many letters. There we go. So no more A, gone. No more S, gone. And now they want me to solve for W. And there's a couple of ways to do it. I just multiply everything by W. I think that's what I did on the work. I think I'll just do that again. So we have RW equals, those W's die, T plus those W's die, P. Okay? And now divide everything by R. And W equals T plus P over R. Or P plus T. It doesn't matter which one's first. It's over R though. Okay? There was another way to do that. You could do it as all one fraction, like you wrote T plus P all over W is equal to R, and then cross multiply and solve. So RW equals T plus P, and then you divide by R, and you still get the exact same thing. All right. Let's look at 21. Eliminate W and R and solve for A. And then we got a couple of word problems. All right. So 21 is eliminate W and R and solve for A. And so T is equal to W over D, R is equal to W plus P, and D is equal to A, R. So let's see, W. So to solve for W, easy enough, cross multiply. W is equal to TD. Solve for R, easy enough, divide both sides by A. R is equal to D over A. And now we're going to take and put those both in here. All right. Yeah? Yeah, let's do that. So D over A is equal to TD plus P. And then they want me to solve for A. Okay. So it's on the bottom here. So let's put it over 1. Put that in parentheses. Cross multiply. So we've got A times quantity TD plus P is equal to D. And then divide by TD plus P. And there we go. Now, I think I did it differently on the work. I got the exact same answer, but I think I took one, substituted it into the second one, and then took that one and substituted it into the third one, which is also fine. I mean, it looks like that was easier to sub it in instead of solving them and putting them both in here and having that mess. You could take this one, put it in there, and then take this one and put it in there, and then it was almost already solved for A. You just divide it out. So either way, it's fine. All right, and now let's finish with the word problems. An airplane flew 600 miles in 3 hours with the wind, and then flew against the wind in 3 hours, and it only got 450 miles. And what's the speed of the plane, and what's the speed of the wind? So look, it's distance equals rate times time again. That's all this is rate times time equals distance. Distance equals rate times time, dirt. And so when you look at this, when you're flying with the wind, it's the rate of the plane plus the wind. That's with the wind rate. And then against the wind would be the rate of the plane minus the wind. That's against. And so if you look at it, it was 3 hours both times. So R plus W times 3, that's with the wind, it got 600 miles. Against the wind, R minus W in 3 hours, it only got 450 miles. Now, it wouldn't have mattered. They could have said 2 hours or 5 hours. It wouldn't matter. We could have anything in there. We distribute these, and you get 3R plus 3W equals 600, and you get 3R minus 3W equals 450. Again, if you want to use the addition method, you add straight down, you solve. That'll be your plane's speed, and then you sub it back in. That'll be the wind speed. I went full on matrix, reduced row echelon form, 3, 3, 600, 3, negative 3, 450. Hit enter. We get the identity matrix with the answers of 175 and 25. So the plane speed is 175 miles per hour for the plane and 25 miles per hour for the wind. Okie dokie. Okay, let's look at 23 and 24. Same things. It's just going to be, we're setting them up a little bit different. Basically, these are all mixture problems in some way, shape, or form. So 23 is literally a mixture problem. They want to mix 10% stuff with 50% stuff to get 40% stuff. They want 200 milliliters total. So every time you set up a mixture problem, it looks like this. X plus Y equals the total amount you want. They want 200 milliliters. And then they gave you 10% solution, so 0.10x, 50% solution, 0.50y, and they want to achieve a 40% solution times the 200. So if you look at it, x plus y equals 200, and then this one just, we put a 10% in front of that, a 50% in front of that, a 40% in front of that. All right? So now look at what that gets me. 1x plus 1y equals 200, and 0.1x plus 0.5y gets me 80. I think it's 80. Is it 80? It's 80. All right. And again, if you want to use the addition method, multiply the bottom by -2. That'll kill the y's. I don't. I want to use a matrix. So RF 1, 1, 200, 0.1, 0.5, 80. Hit enter. 0, 0, 1. That is 50 and 150. So what does that mean? That means X was 50. If you look, X is what I had multiplied by the 10%. So it's 50 milliliters of 10% stuff. And Y is 150 milliliters of the 50%. All right, which makes more sense. It makes sense. You're trying to get a 40% mixture. So you watered it down just with a little bit of 10% stuff, but it's mostly the 50% stuff, right? So there's way more of that than that because you're trying to get to 40, which is very close to 50, but not as close to 10. All right. And then 24, the last one, they literally just give you the formulas. You really don't even have to. Oh, I guess they mix them around. So you had to move the -2 F1 over and the -200 over. So you would end up with -2 F1 plus 2 F2 is equal to 200. And again, you can probably guess how I did it. Reduced row echelon form, RF 1, 1, 600, -2, 2, 200. Hit enter. You get 1001 of 250, 350. So force 1 was 250 pounds and force 2 was 350 pounds. Oh, kilograms, not pounds. Sorry, kilograms. Again, we must have been in Canada, eh? And that is what the test is going to look like.